Hello dear students, I am Ganesh Welcome you all to this session of relation and function. Today we are going to discuss some important concepts of relation and function. Already we have discussed in our previous classes about various type of relations, and we have already proved that how to check a relation is equivalence or not. Yes or no? So आमर प्रीवियस क्लास रे आमे इक्विवेलेंस रिलेशन डिस्कशन करि दिथिले, एंड इन द मूविंग ऑन we are going to congruence modulo relation, and we are checking that congruence modulo relation is an equivalence relation. Yes or no? ए सब पिलाय मन अछि तो ना भूली गलने? मन अछि? Very good. So today we will move to the concept of a new thing, that is equivalence class. That is equivalence class. Okay, so confused about equivalence class? That no, dear students, don't confuse about equivalence class. It is different from equivalence relation. How? We will check it later on. We will check it that how a equivalence class is different from a equivalence relation. Many of the times we observe that students are confused between equivalence relation and equivalence class, but today we will clarify it and we see that how the equivalence classes are obtained. But one thing remember, equivalence classes are obtained from an equivalence relation. Okay, otherwise equivalence relation, if equivalence relations are not there, then equivalence classes are not to be obtained. Okay, so first of all, again we move to the equivalence relation. We are going to find a equivalence relation, and from there we will check the how to obtain the equivalence classes. Okay, so for it, what we do, we take a set. Let us take a set A equal to 1, 2, 3. First of all, we will go with the example. Okay, so remember, example is the better way so to explain or to learn a concept. So I am taking a example, then I will go for the definition. Okay, suppose here A. Now find the product set A on A, that is A cross A. So A cross A is what? A cross A is the ordered pairs. What are the ordered pairs? It is 1 1, 1 2, 1 3, then 2 1, 2 2, 2 3, then 3 1, 3 2, 3 3. Okay, so these are the ordered pairs we obtained. Okay, now take a relation from it, and remember, my dear students, that relation should be an what? Should be an equivalence relation. Okay, not a ordinary relation. We will take a ordinary relation and we see that from a ordinary relation equivalence class cannot be found. So for our convenience, let us take a what type of relation? A equivalence relation. So relations are taken from where? Relations are taken from the product set, that is on A, that is A cross A. So let any relation which is named as R is from A, that is A cross A, and suppose R equal to, suppose I am consisting a equivalence relation, that is 1 1, 2 2, 3 3, the order pair 3 3, 1 2 and 2 1. Okay, so now we check, is it a equivalence relation or not? We will check it. नहीं गले तो हबनी, सेटा हमें चेक करबा को पड़िबो whether that relation is a equivalence relation or not. So previous classes we have already discussed that how to check a relation is equivalence relation or not. भूली गलनी की? Okay, मन रखिछ. Very good, very good. So imagine and think whether it is a equivalence relation or not. Yes, you are correct. It is a equivalence relation as it satisfies the reflexive property. All identical pairs are present. You see, yes or no? It is symmetric in nature. So symmetric property is also satisfied. It is also a symmetric relation. It is transitive also. Yes or no? So as it satisfies all the three conditions, so it is an equivalence relation. ये गोटे equivalence relation हबो. Yes or no? Now I move to the definition, and I found how to get the equivalence class. So keep it as it is. Now we move to the definition of equivalence relation. So sorry, the definition of equivalence class. How to get the equivalence class? Okay, let us see. Let R be an equivalence relation. The definition says, and we will compare it. Comparing both, we will clarify the concept of equivalence class. Okay, so don't be confused. Today we will clarify on this concept. Okay, up to a great extent. इसके बाद कोई डाउट नहीं रहेगा. Okay, so let R be an equivalence relation on A. Okay, yes or no? And let one particular element, suppose the particular element is A and it is belonging to where? It is belonging to the set A. Clear? Then now I am moving to the pinpoint definition. Then equivalence class of A is denoted as so you see, equivalence class is denoted in what type of manner? Equivalence class is denoted in form of square bracket. Okay, and what it contains? It contains B, the element B, such that B is belonging to what? B belongs to A, and the ordered pair BA belongs to R. So you see clearly that equivalence class means it is the set consist by those elements those are related to A in that particular equivalence relation. Say equivalence relation भितरे जो पेयर एलिमेंट जाक ए सहित रिलेटेड हेइथिबे, जो एलिमेंट ए सहित रिलेटेड हेइथिबे सेमानंकर सेट को नेई इक्विवेलेंस क्लास तयारी हुए. ओके, फॉर एग्जांपल here we are taking a particular example. Now take an element 1. Here set A consists of 3 elements, so take a element 1. Its equivalence class, that means therefore equivalence class of 1, okay, how it is represented? It is represented in form of the square bracket. And what it consists of? It consists of those elements those are related to 1 in that particular relation. So you see here 1 is related to itself, okay, and 1 is related to 2. Yes or no? So equivalence of class of 1 is 1, 2. Yes. कहीं ना एटी 1 निजे निज सहित रिलेट हेछि ए पर्टिकुलर रिलेशन रे, ए पर्टिकुलर इक्विवेलेंस रिलेशन रे 1 निजे निज सहित रिलेट हेछि एंड 2 मध्ये जाई 1 सहित रिलेट हेछि. सो इक्विवेलेंस क्लास ऑफ 1 कहिले आमे कहा को नै कि बुझिबा ना, आमे ए भलिया एलिमेंट मान को नै बुझिबा जो माने कि कोन करिथिबे ना 1 सहित रिलेट हेइथिबे. ओके, ऑर्डर पेयर फॉर्मेशन हेइथिबो. Similarly, Therefore, equivalence class of 2, equivalence class of 2. What is equivalence class of 2, my dear students? It is denoted like this in form of the square bracket, and it is equal to those elements, those are related to itself. Yes. So you see 2 is related to 2, 2 is related with 1 also. Yes or no? So the equivalence class of 2 is consist of the elements 2 and 1. Now what is the equivalence class of 3? Now equivalence class of 3 is represented in form of square bracket, and what it contains? It contains those type of elements, those are having the, can be written, those are related to 3. So here you see only 3 is related to 3. Okay, so those are the way to get the equivalence class of the different elements present on set A. Clear, my dear students? Okay, so again we will repeat. Again we see what we write it here. You see, we write that equivalence class किसका होगा? उन element का होगा those are present to set A. Okay, so here you see that in set A 3 elements are there, and how to get the equivalence class? Equivalence class आमे किमिति पाइबा? It consists of those elements, those order, it consists of those elements, those are in form of the ordered pairs and related to the particular element whose equivalence class is going to be found. आमे जो एलिमेंट रो इक्विवेलेंस क्लास बाहर करबा को जाउचे सेही एलिमेंट सहित जे रिलेट हे कि थिबो सेमानकर सेट को नै इक्विवेलेंस क्लास तयारी हुए. So equivalence class of A is consist of those element B such that ordered pair BA belongs to R. Okay, so आमे जहा डेफिनेशन लिखिचे सेही डेफिनेशन को एठी आमे वेरीफाई अगेन करबा. So equivalence class of 1 means it is consist of those ordered pairs, those are related to 1 itself. So 1 सहित को माने रिलेट हे जंदी ना 1 सहित निजे 1 रिलेट हेची and 2 मध्ये जाई 1 सहित रिलेट हेची. So equivalence of class of 1 is consist of those two elements. Equivalence class of 2 similarly it is denoted in form of the square bracket. हाँ ना नहीं? And it is consist of those elements, those are related to 2 itself. So it is related to 2 and it is related to 1. So equivalence of class 2 रे के पाइबा ना हमें 2 को पाइबा एवं 1 को पाइबा. Next equivalence class of 3, it is denoted by the symbol in form of the square bracket, and in equivalence class of 3 हमें को एलिमेंट पाइबा ना जो एलिमेंट सेही पर्टिकुलर इक्विवेलेंस रिलेशन रे थिबो एवं 3 सहित रिलेट करि थिबो. So it is equal to the set 3. Okay, so in this way we are able to obtain the equivalence class of each and every element on set A. Okay, further, so this is the definition and this is the way. Further we will move to another example and we see I am writing some of the relations. You have to tell me whether those relations are having equivalence classes or not. So I want to know when we get the equivalence classes. Yes, if it is a equivalence relation, then only equivalence classes can be found. Okay, so let us take some more examples on the same set. Okay, so I am erasing those things. You see, one relation is taken. Suppose I am taking another relation R1. That is from A. Okay, that is on A, that is from the product set. So R1 is also from A cross A. Suppose R1 equal to 1 1 2 2, 1 2, 2 1. Is it having equivalence classes? ଆମେ ଏଇ ରିଲେସନର ଇକ୍ୱିଭାଲେନ୍ସ କ୍ଲାସ୍ ପାଇପାରିବା କି? ଭେରି ଗୁଡ୍। ଏଇ ରିଲେସନର ଇକ୍ୱିଭାଲେନ୍ସ କ୍ଲାସ୍ ଆମେ ବାହାର କରିପାରିବା ନାହିଁ। we can't able to find. Why? Because it is not a equivalence relation. First of all, the definition says that R should be an equivalence relation. Then only we are able to get the equivalence classes. So here we are not able to get the equivalence classes of this relation. Okay? Unable to get. Now I am writing another R2. 1 1, 2 2, 3 3, 1 3 and 3 1. Okay? I am erasing those two. Suppose R3 is from the product set. Now tell me, is it a equivalence relation? You check and tell me. Imagine, yes, it is an equivalence relation. Yes or no? As it is reflexive in nature, as it is symmetric in nature, as it is transitive in nature, so it is an what? It is an equivalence relation. So if a equivalence relation is there, then only we are able to get the equivalence classes. So who is able to get equivalence classes? Let us try with me. So what we do? We will take the equivalence class of those elements, and we know one observations are clear that equivalence class of what? Each and every element of the set can be found, of the original set can be found. Therefore equivalence class of 1, equivalence class of 1, okay, equivalence class of 1 is what? It is denoted by the symbol like this, and it consists of those elements. Those are related with that one in the particular relation. So you see, with 1, it is 1 is related, 3 is also related with 1. Yes or no? So it is 1 and 3. Now equivalence class of 2 is what? Okay, try to find out with me. Yes, equivalence class of 2 is denoted by the symbol, and it is consist of the single element 2. Clear? Now find the equivalence class of 3. Okay, I am not writing till now. Are you able to find? Very good. Equivalence class of 3 is what? It is again 1 and 3. Why? Because here 3 is related to 3 and 1 is related to 3. Yes or no? So in this way we are able to get the equivalence classes of each and every element. Yes or no? Okay? So in this way, that every equivalence relation has a equivalence class, and you will proceed to find the equivalence class. Clear? Now I am going to write some of the observations on equivalence class. What? Some of important observations which we can write in form of notes also. What is the first note? The first note says equivalence class to every element on A on the given set can be found. यार मीनिंग कौन ना सेट ए रे जेते जाको एलिमेंट थिबे समस्तन को नेकी गोटिए गोटिए इक्विवेलेंस क्लास तयारी हेई पारिबो. ओके, यस और नो? नेक्स्ट इज we will go for the next note. What? how many number of equivalence classes can be found? The number of equivalence classes, how many can be found? That if how many elements are there? Okay. Yes or no? Next we will go to write that equivalence classes are identical or disjoint to each other. Equivalence classes are identical or disjoint to each other. What it means? Now let us check it. It means that what equivalence classes we found. You see here we find the equivalence class of 1, we find the equivalence class of 2, and we find the equivalence class of 3. You see in the 3 equivalence classes, the equivalence class 1 and the equivalence class 3, they are equal to each other. Yes or no? They are identical with each other, and either they are identical or they are disjoint, means no overlapping is there. That is the meaning of disjoint. Clear, my dear students? Yes or no? So these two are the important observations on equivalence class. Clear? Now we will proceed to some more examples of this equivalence class. Okay? So I am cleaning the board now. I am going to elaborate this concept of equivalence class with some more examples. Okay. So suppose in your exam point of view, we are facing many type of problems, many type of questions in your exam point of view that construct this type of equivalence classes. Okay. So what type of questions we are going to appear in our exam? Let us. I am going to tell you some of the examples. Okay. So I am giving an example. So the questions are like this. Give an example. Okay. Give an example of an equivalence relation on suppose on some set, suppose on X. The set is named as X. On X, for which suppose some condition is there. There is a single equivalence class. So we have to form a relation which should be equivalence. Okay. So we have to form a equivalence relation which consists in such a manner that only a single equivalence class can be found. Okay. So for it, what we have to do? We have to do some example we have to take. So let us take a simple example. And the set is named as X. So suppose in the solution I take X as, let X as the set consists of the single element A. Now, so you know the product set is denoted like this: X multiplied by X, and it is the order pair AA. And now you can verify this is an what? This is an equivalence relation. We will take a relation R equal to what? It is consist of those order pair. So this is itself which is equal to X cross X. it is itself the equivalence relation. Yes or no? Now what is the equivalence class? Here the equivalence class of A means what? It is those x such that x belongs to set X and x A belongs to R. Yes or no? So you see A is related to what? It is related to itself. So we are getting only one equivalence class at here. Yes or no? We are getting only one equivalence class. So in this way we can find the equivalence class of a single equivalence class, and for it simply take a single element. Single equivalence class पचारिछि, so single element नहीं गले हमें easily single equivalence class बाहर करि देई परिबा. Okay, now we will move to some more examples. Every question भी पचारता है. I am clearing this one. The question is, give an example of a equivalence relation on X. Suppose, so for which there is a, for which, so what do we have to do? We have to find an equivalence relation on X for which there is a single equivalence class. Single equivalence class consisting of two elements. So हमको एई भलिया गोटे इक्विवेलेंस क्लास तैयारी करिवा को पड़िबो in which only two elements are there. Yes or no? So how to find? You see, for which what we have to do? We have to take an set. Let set X equal to 1 2. Okay, let X equal to 1 2, and suppose you know your X cross X, the product set, that is 1 1 1 2 2 1 2 2. Yes or no? And take R equal to that one 1 1. We have to find an equivalence relation. Yes or no? So I am taking the universal set or the universal relation itself, that is X cross X itself. So that is an equivalence relation. You can verify. Identical property is there. It is symmetric in nature. It is transitive in nature also. Yes or no? So this relation is what? This relation is an equivalence relation. Now we can find the equivalence classes. Equivalence classes means what? We already write in our previous now just before we are writing what is an equivalence class. It is consist of those elements, those are having the ordered pairs. Yes or no? So here equivalence class of 1 is what? Equivalence class of 1 is consist of those elements, those are related to 1 in that particular relation. Yes or no? So equivalence class of 1 is denoted like this. You see, equivalence class of 1 means 1 is related to whom? 1 is related to itself and 1 is related to 2. Yes or no? So equivalence class of 1 is 1 2. Clear? Yes or no? And you can, somebody may tell me, sir, equivalence class of 2. You see, equivalence class of 2 is also 1 2 because 2 is related to 2 and 2 is related to 1. Those pairs are present. Or we can say equivalence class of 1 is equal to the equivalence class of 2, which are consist of the elements 1 2. Yes or no? So we are able to get a equivalence class consisting of how many elements? 2 elements. Okay, so in this way we can find the different type of equivalence classes. Okay, so next Basing on the equivalence class, we will see, or in equivalence class what we read, that equivalence classes are consisting of those elements, those are related to a particular element in the equivalence relation. Yes or no? ସେମାନଙ୍କୁ ନେଇକି equivalence class କେଉଁଠି ତିଆରି କରାଯାଉଛି ଆମେ ଦେଖିଲେ, and equivalence relation ଥିଲେ ହିଁ କ'ଣ ହବ ନା equivalence class ଆସିବ, otherwise equivalence class cannot be found. ଏତିକି ଆମେ ବର୍ତ୍ତମାନ ବୁଝିପାରିଛେ. Okay, next the important discussion is with another concept. Okay, I am erasing and we are going to read another concept. You see, that is partition of a set. That is partition of a set. Yes or no? Partition of a set is the next discussion. So, what we mean by partition? We already know India, Pakistan. गोटे इंडिया थिला दिभाग होइकी इंडिया पाकिस्तान हला. फर्दर इंडिया पाकिस्तान हला परे फर्दर इंडिया रो कौन हला बांग्लादेश पार्टीशन हला. यस और नो? सो सेही परि पार्टीशन माने कोन, गोटे सेट रो पार्टीशन माने कोन, एंड यार कॉन्सेप्ट कोन आज हमें भलो भाबे बुझिबा. ओके, सो द थ्योरी सेज दैट सपोज देयर इज ए सेट. ओके, suppose it is a set and we partition it in subsets. One is P1, another is P2, another is P3 and another is P4. Okay, then each one is called as a partition. Then each one is called as a partition of that set. But we have to look it with sensitively as it has some properties. What are the properties? That those partitions, if you unite them, if you combine them, if you make the union, you will go to the, or you are able to get the total set. Okay, and another observation is there that intersection of any two partitions, there should not be, they are not overlapped with each other. Okay. So with this primary idea, I am going to tell you the exact definition of partition of a set. So the partition, and we will again move to that with some more examples. Okay. So it says, let S be any non-empty set. S be any non-empty set means it has some elements. It should be non-void. Okay. Let P equal to the subsets P1, P2, ... Let P is consisting of those type of subsets. One is P1, another is P2, and so on. B, the non-empty subsets called as partition of S, called as the partition of S if and only if and only if. What are the properties? That P1 union P2 union ... and so on. How many are there? Is equal to what? Is equal to the total set S. And the next one is P1 intersection P2 intersection so on is equal to 5. If you make the intersection between the elements, then the subsets are not having any intersection with each other. Okay. So with this we are reading about the partition of a set. So partition means what? Partition means one set is there. We have to we have to partition it in form of subsets such that their union is equal to the total set, their intersection is equal to 5. They are not overlapped with each other. That is the meaning of partition. Okay. Let us elaborate this concept with some more examples. With an example, because example is the better way of explaining one thing. So what we do, we take an example and then we will move pictorially also. I will represent it pictorially for your clarification. Okay. So you see an example is there. Let A equal to -1, 2, 3, 4, 5, 6. Okay. -1, 2, 3, 4, 5, 6. I am writing some of the collection of elements. Okay. Let the partitions of A are A1 equal to -1, 2, 3, A2 equal to 4, 5, and A3 equal to 6. Yes or no? So is the subsets are called as partitions of A? Is the subsets called as partitions of A? We will verify. What the property says? If I represent it pictorially, you see this is the set A. Yes or no? Now it has some elements -1, 2, 3, and another is 4, 5, and another is 6. It is now I'm dividing in some portions or some subsets. One is A1, another is A2, another is A3. You can observe that their union is equal to the total set. Yes or no? And their intersection is equal to what? Is equal to, they have no intersection with each other. That means the intersection is equal to 5. So it satisfies this condition. Yes or no? It satisfies that condition that their union should be equal to the total set. Their intersection is equal to 5. Then only they are called as partitions. So it is a partition or not? Yes, it is a partition. Therefore the partitions of A are like this. Suppose somebody write A1 equal to -1, 2, A2 equal to 2, 3. Suppose somebody write is a partition. It is a partition. Suppose somebody write A1 equal to -1, 2, A2 equal to 2, 3, 4, and A3 equal to 5, 6. A3 equal to 5, 6. So is it a partition? Dear students, no, these subsets we can't say that they are the partitions of A. Why? Very good, your imagination is absolutely correct that they are overlapped with each other. ସେମାନେ କ'ଣ କରୁଛନ୍ତି? ପରସ୍ପର ସହିତ overlapping ହେଇଯାଇଛନ୍ତି ନା ନାହିଁ? ସେମାନେ ପରସ୍ପର ସହିତ overlapping ହେବା ଯୋଗୁଁ ସେମାନଙ୍କର intersection empty ନାହିଁ. They have not disjoint to each other. That's why they are not forming the partitions. So here this collection, this type of division is called as partition, whereas this division is not a partition. Okay, and you see their intersection is equal to, should be equal to empty. Okay, that is the main thing. If and their union is equal to the total set. On that condition we can find the partitions. Okay. And now I am going to tell a vital information that equivalence classes always forms a partition. How? You see. So what I am writing it here. You see the clarity and what is the relation between equivalence classes, and what I told you that equivalence classes forms a partition. So we will take an example. Another example. Suppose I am cleaning this one also. And I am writing the note, then I will go for the example. What the note says? Equivalence classes forms the partition of the given set. So let us elaborate it how the equivalence classes forms the partitions of a given set. Let us elaborate this concept. Okay. So we will take an example. Let A equal to 1, 2, 3. Find the product set. It is 1, 1, 1, 2, 1, 3. 2, 1, 2, 2, 2, 3. 3, 1, 3, 2, 3, 3. Yes or no? Suppose we take a equivalence relation R on A, that is from A cross A, where R equal to, suppose I am taking R equal to this one. Those ordered pairs are present in R. Clear? Now you see, it is a equivalence relation, and here it is a equivalence relation. Honestly, na believe. Very good, very good. It is a equivalence relation. आम एठी कौन करिबा ए इक्विवेलेंस रिलेशन जदि प्रेजेंट अछि we are able to get the equivalence classes. Yes or no? Therefore equivalence class of 1 already we are able to find the equivalence class of 1. What are those equivalence class of 1? It is the set 1 2. What is equivalence class of 2? Equivalence class of 2, it is the set 1 2. What is equivalence class of 3? It is the set consists of 3. So you see here equivalence class of 1 equal to equivalence class of 2 equal to the set 1 2. And there is another equivalence class, that is 3, consists of the single element. Yes or no? So you see both are disjoint to each other. You can see picturically the set is named as a, it is 1 2 is there and 3 is there. Yes or no? So in this way we are able to verify, or we can say that equivalence classes forms the partitions of a given set. Yes or no? Clear? Now again elaborated this concept with another type of equivalence relation. Now gote equivalence relation neiki dekhiba je equivalence classes a type of partition formation koruchanti ki. Here we are able to verify it, but let us take another example. Okay? You know that in our previous session we are reading about the congruence classes or congruence modulo n. Yes or no? And we already checked out that congruence modulo relation is an equivalence relation. Congruence modulo relation ti kon hobo? Gote equivalence relation hobo. In our previous class we already verified it. हमर प्रीवियस क्लास रे आमे कोन करछे कॉन्ग्रुएंस मॉड्यूलो रिलेशन गोटे इक्विवेलेंस रिलेशन हबो बोली वेरीफाई कर देछे यस और नो सो आमे आज कोन करबे से कॉन्ग्रुएंस मॉड्यूलो क्लास नेबा ऑन इंटीजर्स सो आई विल टेक एन एग्जांपल let z be the set of integers consider a is congruent to b modulo 3 a is congruent to b modulo 3 so a is congruent to b modulo 3 means what it is related here a is related what it is a is related to those elements where the difference is equal to divisible by 3 yes or no so here how the equivalence classes are obtained and how the equivalence classes forms the partitions okay let us verify it means what it means therefore equivalence class of a means what it is those elements b it is consist of those element b belonging to where belonging to the set of integers such that b is congruent to a modulo 3 yes or no b is congruent to a modulo 3 or we can say similarly you can write for b also it means it is those b belonging to z such that it is b is congruent to a modulo 3 means b minus a equal to 3k where k belongs to z yes or no or it is equal to what we can write as it is b equal to a plus 3k it is equal to a plus 3k yes or no it is equal to a plus 3k where k belongs to z yes we can write it as a plus 3k so equivalence class of a means what equivalence class of a means it is those elements those are related with each other therefore in this way if we put the element 0 what is its equivalence class with which it is related you see it is related with if I put k equal to 0 I will get 0 if I put k equal to because a is 0 okay so a is taken as 0 0 plus k is taken as 0 so 0 plus 0 is what 0 if I put k equal to 1 what I get 3 if I put k equal to 2 what I get sorry I will get 6 and 9 and so on if I put k equal to minus 1 what I get minus 3 minus 6 minus 9 and so on yes or no similarly what is the equivalence class of first of all I am writing then the congruence class of 1 modulo 3 it is written like this and similarly it is equal to what it is consist of those elements 1 4 7 10 and it is your minus 2 because if I put k equal to in place of a if I keep it as 1 plus 3 that is 4 1 minus 3 minus 2 and similarly minus 5 and so on and similarly for 2 congruence modulo 2 what do we get 2 5 8 11 and so on and it is your with 2 if I put 2 what I get minus 1 minus 4 and so on so you see these are the 3 congruence classes or 3 equivalence classes obtained by the modular relation confused हे गलो पिला again I told you as it is a larger set as it is a integer set of integers आमे जानि छे जे congruence classes गोटे इक्विवेलेंस रिलेशन तैयारी करती आम जाने ना नहीं सो से ही कॉन्ग्रुएंस रिलेशन मानक नेली कॉन्ग्रुएंस रिलेशन नेली दीटा एलिमेंट भितर क्या नहीं कि पर्टिकुलर वैल्यू एम रो कौन नेली 3 नेली ओके सो वर्तमान तुम देख आम जदि नंबर सिस्टम रे देखिबा इंटीजर सेट रे देखिबा सपोज मो पर्टिकुलरली नेबी 0 नहीं कि 0 रु को 0 कहा सहित रिलेट है 0 रु को संख्या माइनस कले से 3 रे भाग हबो इट इज डिविजिबल बाय 3 यस नाउ यू आर करेक्ट ना 0 रु 0 माइनस कले से 3 रे भाग हबो 3 माइनस कले भी हबो so 0 is involved with those type of elements suppose I take 1 okay then I get this type of elements if I take 2 I get this type of elements okay so they are congruently related or they are forming the equivalence classes means we are writing in the smallest positive value but if you see the congruence class of 2 is equal to the congruence class of 8 the congruence class of 2 is equal to the congruence class of 11 but in a short notation we are writing by the smallest positive value okay because again the values are repeating as we are saying a plus 3k repeating okay so a equivalence classes formation heichi and now you can verify that those equivalence classes what we verified at what we obtained at here they are forming what they are forming the partitions because you see they are not overlapping with each other semane परस्पर सह ओवरलैप करि नाहंती and their union is equal to the total set Z सेमानकर यूनियन टा total set Z सहित equal है yes or no so in this way we are able to get that the equivalence classes with respect to the modular relation congruence modular relation are forming the partitions so what I can say therefore I can write therefore congruence modulo 3 union congruence modulo 1 union congruence modulo 2 is equal to the set Z okay and their intersection is equal to 5 yes or no so we can say that congruence modulo classes also helpful to form the partitions and it divides the integer set of integers in some subsets okay or they are able to form the partitions so this is some of the information about the partition of a set and about the equivalence classes okay so my dear students here we are completing all the informations of a relation in our previous lectures we have discussed about the introductory part of relation we have discussed about the types of relation here today we discuss some of the important properties that is on the equivalence class and on the partition of a set okay so yet here we are completing the relation and we will move to function in our next class okay so thank you to all.